Hello, I'm Clint Panion. I'm in Mr. Wood's ME350 Thermodynamics course. My last name starts with P, so I'm doing problem 7. Here's problem 7 from the homework packet. We have a closed rigid tank containing a two-phase liquid vapor mixture of refrigerant 22, initially at 20 degrees Celsius with a quality of 50.36%. Energy transfer by heat into the tank occurs until the refrigerant is at a final pressure of 6 bar. Determine the final temperature in degrees Celsius. That's the first question. The second question is, if the final state is in the superheated vapor region, at what temperature in degrees Celsius does the tank contain only saturated vapor? So the equations we're going to be using in this problem are a lever rule and the specific volume equation with the quality factor in it. The reason I knew to use these equations is that it mentioned quality factor. That's a giveaway. So what we're told is state 1 it has R22 and state 2 has R22. We're given the temperature at state 1 and the quality factor at state 1, and we're only given the pressure at state 2. But it's told that volume is constant and mass is constant, therefore the specific volume is constant. And if you didn't know, the units for specific volume is meters cubed per kilogram. If you're confused by that, just imagine density, because specific volume is just density flipped. So we're going to start off by just using the specific volume equation. To find the values for the saturated liquid and saturated gas specific volumes, you're going to have to go to page 13 of the fluid properties PDF that was given in the assignments on Canvas, and look at table A7 at negative 20 degrees Celsius. So here is table A7. You're going to look at the specific volume column and go down to negative 20 degrees Celsius. Here we see 0.7427 times 10 to the negative 3 is the saturated liquid, and 0.0926 is the saturated vapor value. If you're confused by why it's 10 to the negative 3, up here it says VF times 10 to the 3, so the values listed here are actually 1/1000th of what you see. So you just plug in your values into the equation, and then you get a specific volume value of 0.0470 meters cubed per kilogram. What we're going to do with that value now is look at another table on page 17. This table is table A9. And we're going to use the pressure value given to us in state 2, 6 bar. So we're at 6 bar of R22's specific volume table. So you go to the column here that says specific volume, and you're going to look for the ranges that are close to the value we found, which was 0.0470. So you look at the temperatures in degrees Celsius here, you're going to see it's in between 40 degrees Celsius and 45 degrees Celsius. And if you notice that 45 degrees Celsius, it's 0.04724. And in my opinion, if I was being like loose about it, I would be like, hey, that's pretty close to the actual value. Maybe the final temperature is just 45 degrees. Because the only difference is 0.04724 instead of 0.04720. But we're going to be a bit more precise and use the lever rule. So we're going to take from that table, we're going to take the values for 40 degrees Celsius and 45 degrees Celsius and use those specific volumes that were listed. And we're going to find the final the temperature where the specific volume is 0.0470. If you don't understand lever rule, basically it's just saying the slope from here to here is equal to the slope from 40 degrees Celsius to whatever temperature we're looking for. So you're going to plug in your numbers all the way over here, and then you're going to get your final temperature of 43.75 degrees Celsius. And that's the temperature in state 2. So that's the answer to the first question, determine the final temperature. As for the second question, if the final state is in the superheated vapor region, at what temperature does the tank contain only saturated vapor? For the way I interpreted this was the specific volume value we found, 0.0470, is going to be the saturated vapor value. So you look at your a generic TV diagram we have here. You have your compressed liquid phase here, you have your superheated vapor phase on this side, and then you have your vapor dome here. The values that are directly on these vapor domes, those are your saturated liquids, and this is your saturated gas. So here, this is 0.0470, so we're trying to find the temperature that's related to that. And in order to do that, you go back to the table A7 from before, you look at this column, saturated vapor, you look for 0.0470, and hey, it's right there. You only have to use Weber rule. So go to the temperature here, and it's 0 degrees Celsius. And that is how I got 0 degrees Celsius. And yeah, that's pretty much it. That's how you do number 7.